name's Alan Robinson. I'm a faculty member here at Carnegie Mellon. I'm a faculty member in mechanical engineering and engineering and public policy. My research investigates environmental impacts of energy systems, focusing on air quality. One of my current thrusts is focused on better understanding the impacts of car and truck emissions on urban air quality. The air quality benefits from these regulations have been less than anticipated. This points to gaps in our understanding. We run cars on something called a dynamometer, which is a treadmill for a vehicle. And it's pretty incredible when you see a big heavy-duty diesel truck going 80 miles an hour on a treadmill. It's a little scary, actually. And then what we do is we sample these emissions into what's called a smog chamber, which is essentially an environmental chamber where we can study their atmospheric evolution. And then we expose those emissions to sunlight and study how those emissions evolve in the atmosphere and essentially what happens to those particles. These experiments have demonstrated that in the atmosphere there's substantial production of new fine particle mass. Essentially, gaseous emissions from the vehicles are being oxidized in the atmosphere and creating new particles. The amount of new particle mass can be 10 times greater than what's coming directly out of the tailpipe. This has really been a change in our understanding of how emissions from vehicles impact air quality. We're currently working with scientists at EPA to implement this new understanding we've developed in these large models that they use for doing regulatory assessments. The goal is if we have a better understanding of how those emissions are transformed in the atmosphere, the models will point us to more effective regulations.